Good afternoon, everybody. When you think about the problems that are around the world, it can be overwhelming. But if you work with folks in your local community, a little bit of effort here or a couple of hours here can really make a big difference. And so I want to introduce you today to justserve.org. My name is Mike George. I'm a Principal Solutions Architect with AWS. Justserve.org is a website that links the volunteer needs of a community to folks who are willing to do that volunteer work. And in order to meet their growing worldwide need, JustServe needed to move from their legacy on-prem infrastructure into something that was cloud native. And so today you're going to hear about that journey that JustServe went through, and you'll learn about those lessons so that you can effectively migrate your workloads to the cloud. I want to introduce you to Steve Coleman, who is the portfolio architect of the Church of Jesus Christ of Latter-day Saints, who's going to walk us through that journey today. So Steve, I'll turn it over to you.
All right, thank you, Mike. I'm excited to be here with you and share our cloud migration journey and how we've used it to address our challenges. I'll start out by sharing a little bit about who we are and what we do. We'll then dive into where we were and how we've begun using our cloud migration and modernization to address our challenges. I'll spend a few minutes discussing some challenges that we're still facing, and we'll finish up with a discussion on what's next. JustServe launched in 2012 in Silicon Valley, California as a free platform to connect volunteers and organizations and provide opportunities for people of all walks of life to provide service to their fellow man. Organizations will register and list projects from large-scale efforts down to small projects for just a handful of people. Volunteers can then register, search for projects in their area, and sign up to help. You can search for interests such as animals, crisis support, environment. You can look for projects that match your skill set. Once you've found something that interests you, it's as simple as clicking volunteer. From mentoring the young to providing companionship to the young at heart, from helping someone walk a mile in their own shoes to serving our furry and four-legged community, the opportunities are nearly endless. Since its inception in 2012, JustServe has grown to over almost 1 million users, with over 17,000 distinct organizations having listed over 150,000 projects. Now, we started where many organizations start, with a simple 3-tier architecture. We had a load balancer to distribute traffic to multiple front-end servers. Our front-end servers handled both static and dynamic content, all served out of a single data center in the western United States. We had an API layer that handled requests from the front end. The API layer then made calls to our databases and other external services. And this worked just fine at first, but we quickly ran into some challenges. First was that serving traffic out of a single data center did not align with our plans to grow the application globally. Serving traffic, including static assets, from our front-end web servers meant that every page load or refresh had to come all the way back to our app to fetch the content, which is not an ideal situation for your users, especially in areas of the world that have limited bandwidth. Second, deploying the application to on-prem VMs meant that scaling was a painful manual process that required weeks of advanced planning. As an example, we partnered with a prominent YouTuber to market and promote our site. Planning and provisioning the additional VMs for the expected increase in traffic had to be done weeks in advance, which made it all the more frustrating when that demand never actually materialized, at least not to the level that we'd hoped. Afterwards, that additional capacity was almost as difficult to get rid of. And that's just the capacity that you can reasonably anticipate. Planning your application's expected traffic is a lot like the stock market or fantasy football. You can look at all the signals, metrics, and indicators that you want. In the end, without the elasticity afforded by the cloud, you'll end up with both capacity that you planned and purchased going unused, as well as unexpected demand that exceeds your provision capacity. Finally, monoliths, even ones that masquerade as N-tier applications, are difficult to optimize. both the application and the team in developing and supporting it. In our case, we have a read-heavy application with relatively few writes. But because it's all the same code base deployed on the same servers, reads and writes compete for resources, and your VMs have to be over-provisioned to handle those heavy read operations. And the challenges to optimize extend beyond the deployed resources. Monolithic applications tend to breed monolithic development practices. New features are often difficult to add because of their potential impact to other unrelated features. Full regression tests have to be run to make sure that adding a new feature doesn't break any of the old features. And with multiple developers all in the same code base, you find yourself spending a lot more time than you'd like resolving conflicts, both in source control and in personnel. We went into this journey looking for a way to have an application that scaled with our global demand. Even though we're not quite done yet, unlike Bono, we did find what we were looking for. In the past year alone, our user base has grown by over 200,000 users. The number of organizations we support has increased by over 2,000, resulting in an additional 5,000 active projects. Since its inception in 2012, we've also expanded from Silicon Valley, California, to operating in 17 countries and 6 languages. In the process of working towards those goals, we've also unlocked some additional benefits, which I'll highlight later on. But first, let's take a look at how our architecture evolved to support a scalable, resilient, global application. So we look at some of the components of this application, it's still just a simple n-tier architecture with a few additions. Now we use CloudFront to serve our static assets out of S3, which greatly improves the global user experience and the cost and performance of serving those assets. Moving the application layer from on-prem VMs to ECS Fargate, we're able to take advantage of built-in autoscaling, allowing us to ramp up to handle the high demand and cool down when the demand does. The move to Fargate for us was almost as simple as wrapping the application in a Docker container and deploying it. Fargate integrates seamlessly with elastic load balancers, including automatically handling autoscaling. Migrating from a legacy on-prem database to Amazon Aurora and adding a caching layer for our frequently queried data gave us a much better path to optimize and manage our data access layer. Based on our needs, we chose to use DynamoDB for our cache. But the beauty of the cloud is that there were multiple other services that would have fit in there just as well, like OpenSearch or Elasticache. And just because we chose DynamoDB initially doesn't preclude us from making a different choice and swapping it out for something else as our needs and our architectures evolve. Migrating to the cloud is not only, like I said, about building a scalable, resilient architecture, it also enables the next feature to be added and integrated much more seamlessly than traditional monoliths. When the time came for us to add a newsletter subscription, we were able to do so with almost an entirely serverless architecture and without disrupting the main application. We're able to take advantage of asynchronous processing and built-in reliability and error handling without affecting the components of the web or the mobile application. We use API Gateway and Lambda to provide a simple, scalable, inexpensive API to take in those newsletter subscriptions. We use scheduled event bridge rules with Lambda and SQS to handle sending out those newsletters, allowing us to take advantage of some built-in integrations with Lambda and SQS, like automated retries, batching, dead letter queues. Now, not only did AWS enable us to create a more scalable architecture, it also provided a foundation for us to improve our DevSecOps practices. Using a combination of infrastructure as code, CI/CD pipelines, and database scripts, every pull request kicks off a pipeline that deploys ephemeral resources to run thousands of unit, integration, smoke, and other tests. And at the completion of those tests, all of those resources are automatically cleaned up. This gives us several benefits. First, new code can be tested in isolation without worrying about what changes might have been made to an environment that could pollute your tests. One of the foundational principles of DevSecOps is shifting left, and having a full isolated environment for each pull request gives our developers and QA the feedback that they need early and often. There's far less risk of bugs or misconfigurations going uncaught. The use of ephemeral test environments also helps us keep our costs at a minimum. We aren't paying for resources to sit idle, waiting for developers to clock in for the day and come to work. Now I say almost no need here because there are a couple of things like Aurora clusters and load balancers that don't lend themselves well to being created and destroyed multiple times throughout the day. So we use those in other ways. For instance, rather than create a new load balancer for every pull request, we simply modify listener rules on a shared load balancer as we spin up our Fargate instances. Having the creation of the environment scripted all the way down to the data means that failures in the tests are no longer caused by subtle changes in the environment that are not only unrelated to the changes you're testing, but also not likely to happen in another environment. Using a fully functional environment for our internal dependencies, combined with mocks for our external dependencies, helps us ensure we're testing just the right things and that our internal components and interfaces stay stable. Now, we've gained a lot through this journey, including hindsight. So let's talk about some of the things I wish we had known. First, optimizing is different when you're paying for consumption rather than for fixed resource costs. On-prem servers cost a certain amount, no matter how over or underutilized they are. But wasteful and careless development practices will show up as real dollars on your cloud bill. Slow code execution translates into Lambda runtime charges. Overly chatty applications can drive up network and data transfer charges. In short, cloud math is a little different and requires a lot more discipline from your dev and your FinOps practices. Observability is also crucial, and it looks different when you're dealing with asynchronous and serverless processes. Traditional uptime metrics may not apply, and you need to understand how to monitor your application end to end to protect and optimize your user's experience. Auto-scaling still requires you to think about your application's workload and profile to determine which metrics best represent your load. It's also not instantaneous. And it's important that you understand your application's unique signals so that you can react appropriately and in time. You don't need to pay as much attention. You also have to think a little differently about your application's initialization time. It's not something you pay a lot of attention to with infrequent deployments to on-prem VMs, but when you start auto-scaling or dealing with serverless resources like Lambda, trust me, you will notice every millisecond. Just as with great power comes great responsibility, with many options come difficult choices. Understanding your workloads, your data, access patterns, and queries will help, but don't be afraid to try something new here. Try not to let familiarity with an existing database technology exert undue influence on your future architecture choices. AWS has multiple purpose-built databases like DynamoDB, OpenSearch, or Neptune. Do your homework and pick the database that's right for your architecture. Cloud migrations can also feel a lot like games of Jenga, where pulling the wrong piece at the wrong time can have broader impact to the broader ecosystem. Proper dependency mapping and communication among your dev and operations teams are essential. Let's talk about some of the challenges that we're still working through. When we started, we were using Amazon Aurora, but not Aurora serverless. We have recently switched to Aurora serverless, but not before an announcement about our site in our church's global conference caused our site to crash because the database couldn't add additional reader nodes fast enough to handle that sudden spike in demand. Now, many of our development teams are used to being able to show up to work, plug into the corporate network, and have persistent access to all the resources they need. Moving to a model where things like accounts and VPCs are more tightly controlled and isolated has been a new experience. Things like requiring a Bastion host to log into databases, or having short-lived credentials that have to be refreshed, are new for a lot of our teams. In addition to security, many of our devs were used to having their environment always deployed and configured just the way they liked it, treating it like a pet instead of a fungible, replaceable resource. Having infrastructure defined in code so that it can be deployed when needed and torn down when not in use is a new paradigm for many. Now, maybe your application is completely greenfield, but more likely, you already have an app serving real users, and it's important to understand that application's components and makeup. What type of assets does your application use? Where and how do you store data? What type of dependencies do you have on external APIs or other systems? These are all questions that will help provide the necessary context for making good architecture choices as you migrate and modernize. What are you looking to get out of this? This is a question you have to ask yourself. What are the business drivers for you migrating to the cloud? Maybe you don't need a global presence, but instead prioritize availability or latency. Maybe there's some regulatory concerns that you're struggling with. Whatever the case may be, understanding the value that you expect to realize is critical to help keep you focused when you run into walls on this journey and find yourself asking, why are we doing this again? Now finally, and maybe most importantly, don't wait. Or at least don't wait too long. The cloud is a vast ecosystem, and you don't want to enter it without any preparation, but you'll never make progress if you wait to do anything until you feel like you can do everything. You don't need to know your final state architecture. Something I'd argue is unknowable. You don't need everyone on your team to have an AWS certification. Pick something small and get to work. Modernization and migration are multi-step processes. As Andy Jassy famously said, there is no compression algorithm for experience. The sooner you start, the faster you'll learn. Make a plan to address your knowledge and skill gaps, but remember that the tools, applications, and services provided by the nonprofit community serve real and immediate needs that are only growing in size and urgency. So start building and start serving those needs today. Thank you.
Thanks, Steve. I really love understanding the journey that Just Serve went through as they went to the cloud. If you'd like to learn more about Just Serve, or if you'd like to volunteer for opportunities in your community, scan that first QR code on the left-hand side. If you're interested in some additional nonprofit sessions, we have 2 listed here. The first is in about an hour at the MGM, and the second is tomorrow afternoon here in the Venetian. And finally, if you're a nonprofit organization and want to connect with AWS, scan that QR code on the right-hand side. And with that, we'd like to thank you for your time, and please remember to fill out the survey in the app. Thank you.